So it's an OpenSUSE-based image with all the required libraries, what we call a runtime environment. So this work is actually based on the previous work by Eric Hendrickson. And we also have the CoprHD RPM installed in the image, so it's ready to be deployed. To do that, we've added a new Docker target to the CoprHD repository. And in order to build that, we only need to run this make command with build type equals OSS. And the outcome will be a Docker image named CoprHD DevKit. And so once we have the image, we're ready to deploy it. We can use the same image to deploy all kinds of deployments, including standalone 1+0, and in theory, we're able to deploy 2+1 and 3+2 as well. Before we can do that, there are two major problems we have to solve. The first one is how can we assign a static IP address to the container once it's deployed? And the other one is how can we access those containers from outside of this Docker host, which will make use of NAT. So a little bit more on the static IP address. Well, as we all know, CoprHD needs static IP address for all the services to communicate with each other, but by default, Docker doesn't provide a static IP address. So when it starts a container, it automatically assigns a dynamic address from a internal subnet, and you can't know what the address is until the container has been fully started, and that's obviously not what we want.
So did you guys look at host networking mode, where effectively it bypasses all that Docker, turns off all that Docker networking stuff, and the container just has access to the host's network?
Yeah, actually,
that might be another way, just as a short term, until this live network thing is here.
Exactly, that's a very good point. But as you know, if we use the host mode, then it means we can only deploy one container on the Docker host, right?
Well, so why would you want more than one container on the same physical host?
I kind of
maybe for testing purposes or something. You can test the cluster just on one node.
Yes. Well, actually.
Okay. I got it. I understand.
Yeah, I'll talk about that in the slides after that. Actually, the multi-node deployment currently has a restriction that all the containers must be on a single Docker host. Yeah, we'll get there. So Docker actually provides a manual way to do this. Assigning a static IP address, but it's quite complicated. And it has a future plan to support this by rewriting the lib network. And it will provide some simple CLIs named Docker Network and Docker Services, but that's only an experimental feature in the latest Docker distribution. And for now, we're using a third-party script called Pipework, which basically does all the manual steps in an automatic fashion. I'm sorry. So here's a diagram that shows how this thing works. So basically, when we start Docker, it'll create a bridge named Docker 0 on the Docker host. And we already have a Ethernet 0 interface for the Docker host, which handles all the network traffic. And in order to assign a static IP address, we have to create a pair of peer virtual Ethernet interfaces. One of them is with vEthernet, and the other one is passed over into the container and named ETH0. So vEthernet is bind. Actually, both of those interfaces are bind to the Docker 0 bridge, so that any traffic that reached one end will automatically be forwarded to the other. And we're using NAT rules so that all the access to port 443 and 4443 are redirected into the container. For the rest of the access, they're just directly to the Docker host as usual. And here, this covers what we have for deploying multiple CoprHD deployments, like the 2 point. In this case, it's 2+1. This is actually done by directing the traffic to the VIP instead of any specific IP address of the container. So in this case, we have 3 containers, .1, .2, and .3, and we have a VIP at .4. So CoprHD guarantees that there's always one and only one container that can have the VIP. So the NAT guarantees that all the access to those 2 ports are always directed to the VIP. So if container 1 has the VIP, then the network traffic goes to container 1. If container 1 is dead and container 2 goes up and take over the VIP, then the traffic is automatically forwarded to container 2. But as you can see, there's a limitation that all these containers have to reside in the same Docker host and share this Docker 0 bridge. That's a limitation for now. I guess that's so much.
I mean, maybe for the multi-host case, you could just go back to Docker host networking mode.
Okay.
But anyway, for development, it's pretty convenient because.
No, I know. I'm not saying don't do this. This is great if you want to run one host, but if you also want to support the container mode on multi-host in advance of with network and whatever, you can probably go just have a different mode where it's running in host networking mode.
Absolutely, but considering that they just added this experimental static IP support to Lib network in August, we may also take one more look at this thing.
Yeah, absolutely.
So here I have 2 VMs. So this VM is actually an OpenSUSE dev kit, and another VM is a Ubuntu VM 14.04, and this I think is 13.2. I've already had the image built to save us some time. It'll take normally like 15 minutes or something, 13 minutes. And once the image is built, we can see that from Docker image. So it's here. So CoprHD dev kit built 27 minutes ago. And
why is it so big?
Yeah,
why is the image so big?
Unfortunately, it is. It's like 900 megabytes. And
so why is that? Yeah.
Well, first of all, it contains multiple layers. In this case, I think about 7 or 8 layers. And the thing with Docker image is that with the number of layers going up, the size accumulates. There's no way for a layer to reclaim any space that's previously occupied by other layers. So
basically, Yun is starting using this thing from the publicly available OpenSUSE image, and even if you delete everything that we don't need from this image, if you strip down this OS, size doesn't shrink.
No, but there's an OpenSUSE image which is 90 meg.
Yes, but if you add, I mean, so yes and no. So we start from this 90, we add Nginx and dependencies and so on, and it grows very quickly. So
yeah, actually, here's a brief history of.
He's basically building also on this thing, so he needs compilers that he can delete, or JDK that he can delete later, but it doesn't shrink.
Well, pretty cool. So actually here it takes most of the spaces. I think it's primarily due to a library that we installed called AAA_base. I'm not sure if that's removable. Because honestly, I'm currently based on the previous work of Eric Henderson from the ADG team, and he offered this as a starting point for me. And as you can see, the RPM image is like 100 megabytes, and after install, it'll take like another 200. So that adds up.
Okay. Yeah.
Okay. So once we have this image, we will need a script to do everything we've just talked about. And in order to do that, we have written this fairly simple script in shell. So the first part is actually on the variable definitions. It's nothing, and this is just cleanup. And this makes sure that Viper, this pipework thing gets properly installed, and the necessary directories are created. Actually, there's one thing I would like to mention. We're using an external volume for the data directory, so that even if the container is destroyed, we can always redeploy another container and be able to resume the previous work with the /data directory shared as an external volume. And here we create this OVF properties, OVF env.properties, and this file is actually shared into the container via another external volume. And here we actually start this container with no network access. And we config the network using pipework here. And after that, we config the host name and populate the etc host file. And the last step is to add the NAT roles so that they can be accessed from the outside. So by that, I mean, so LGLBV160 is the IP address of my dev kit here. Well, the container is inside of it. Let's get into the container really quick. So inside the container, it has no knowledge about the outside IP address, and this IP address 172.17.01 is actually not routable from the outside, but with the NAT rules in place, oops, here, with these NAT rules in place, all the access to 443 and 4443 are redirected to the VIP at 0.2. So if we point the browser to, so by default, the default port is 443, then we'll have access to the container. And we can log in and do all the stuff. So I'm going to leave it right here, and let's take another look at the Ubuntu server here. So once we built this Docker image, we have an option to upload it directly into the Docker Hub and make it publicly available to all the developers or whoever. So from any server with Docker installed, so like here we have Docker installed on the Ubuntu, we can pull the image from the remote repository, in this case, Docker Hub. And once we have this image here, all we need is a slightly different version of the deployment script. Well, for OpenSUSE and Ubuntu, the difference is minimal. Just a bunch of extra sudos will do the trick. Well, for other systems like Mac OS or well, actually CentOS is pretty much the same. CentOS, I mean. For Mac OS, it's going to be a little bit different because by default it doesn't have IP tables, but that's just trivial. Let's take a look at the updated deployment script. So all I have is I added a bunch of sudos here, and we can deploy it. Oops, I'm sorry. So in order to do that, I actually have to retag this image to CoprHD dev kit. Or alternatively, I can just modify my deployment script and look for this for this image instead. Okay, I just changed this, so really shouldn't do that. Let me change it back really quick. Yep. Whoops. Anyway, let me see if I have this inside. Okay, it actually has the IP addresses configured, and all we need to do is wait for Nginx to start. It'll take some, I don't know, 5-6 minutes before Nginx fully starts on this. But while we're waiting, is there any questions, comments on this?
So you showed a picture of the three with the VIP. Is this actually deploying all three, or one? You need to deploy three of them and then put them together, or?
Well, actually, you will have to deploy all three individually, and you have to tune the OVF-env properties file so that these three instances actually know each other. But the thing is, we currently do not officially support multi-node.
Okay.
So, CoprHD.
Yeah, and for development, I don't need three anyway. So.
Yeah, it's just the technology that we use to make it possible in theory. And actually, I've already verified that KeepAliveD will work in this mode so that the VIP will fail over between the containers.
It's something we can look at. I mean, we do have support commercial versions of SQL 5 for each other. Maybe the same technology can be used for attaching multiple nodes to a one fiber.
Okay. Yeah, I agree.
I have one node and say, okay, I install another one, it's let me out and have them without the same connection. Like this for
And also, once this lib network thing becomes officially supported by Docker, we can rewrite this deployment script, and we basically will remove the limitation that all the containers should reside on the same Docker host. Because right now it doesn't make much sense. Because
how does one get access to this code if you're not, this proof of concept work? What's the publish schedule? Is it going to be up on GitHub or Stash or whatever?
I know. So the Docker target, the mate file, or actually the Docker file, is already in the code repository. But the deployment script, the reason I didn't put it there because first it's just for demonstration purpose only, and second it uses third-party script called Hyper, which I'm not sure is totally legal or not. So that's the only reason I didn't put it to the code repository. But I have all the information in the CoprHD wiki as well. So it covers everything I presented and in the slides with a little bit more detail. So I think.
Right, we cannot decipher it, but we can put the script out there.
You put a recipe out there on how to.
Yeah, actually we did. They're in the wiki as well. So.
But we can
post a script.
Okay. Okay. Cool.
Right. There's that upload. Like, for all Docker scripts, you could just have it there, and people can download it.
Cool.
What did you have to change?
Okay, so you didn't show, but you can basically build this entire Docker image even if you run this make Docker thing, right? And also, I mean, because if you have the Docker file, you can build this on Docker Hub directly.
Well, actually, you don't. The only reason I changed those from a specific enter a specific user to a local image is that's hard coded in my deployment script. If I revise my deployment script to reference to the remote image, then it'll automatically pull the image from Docker Hub, and
Don't have to rename.
yeah, we don't have to.
Great.
Let's see how this goes. Okay, it's working, starting. So theoretically, we should be able to access this from the web server as well. Okay, so this is actually all I have for today. So with Docker, we can easily deploy this Docker image on OpenSUSE, Ubuntu, and I believe on CentOS as well. So theoretically, any Linux distribution with Docker support.
Okay, so with this Docker container, can I have workspace with the code checked out from Git on my whatever Ubuntu VM and build inside of the container?
A container, yeah, actually we can.
You can basically have the full build environment inside, and you can also get the runtime environment, right?
Exactly, and actually that will make it more like a dev kit. Right now it's more like an appliance, and if we have all the libraries required for compiling the code, like JDK and others, it'll be easier to share the dev kit to all the community developers, I think.
Okay, so it's just that I need to put my workspace either on the same volume that is used for this database persistence, or I need to attach another directory, the volume inside, to be used for my workspace, right, if I want to be...
Well, it actually can work both ways. If we put all of them inside the container, then we might be able to make an automated build or from CI like Jenkins or whatever, and publish that to all the developers. And for each individual developer, you can always choose to use your own code base and use it as an external volume and mount it into the container and do your job. And actually, this is one of the future work that I'm planning here. So I built the CoprHD RPM inside the build container, and perhaps even publish the Docker image on the Docker Hub in an automatic fashion. And of course, first of all, is figure out a way to trim the size of those images. And if we sort of cover this, when the Docker network command is officially supported, we can update the deployment script to make it more, official. So I think that's all what I have for today. Hope you like it. Thank you.
Thank you, Ian.
Great, thanks.